Now that we've seen the relationship between the trig form of a number, which is also known as polar form, and the rectangular form of a complex number, we can use that information to find the powers of complex numbers and find the roots of complex numbers. In order to find powers and roots of complex numbers, you want to work with the number in polar form, in trig form. So that's why we needed to be able to do that conversion first. Now here's our first theorem. It says that if we want to find the power of a complex number, which is what this left-hand side says right here, then all we have to do is apply the power to the r and then multiply the angle by that same power. So the power is used twice. And you'll see it here on the shorthand notation. I'm raising r CIS theta to the n. Then n is going to be a power on the r, and it's going to be multiplied by the angle. And so that's all there is to the theorem. It's very easy to do as long as you have the problem or the number written in trig form. So here we want to find the 8th power of 1 plus I squared root of 3, which is in rectangular form. We want to give our answer in rectangular form, but we have to remember to convert to trig form to do this work. Now there's a way to convert. We've already done conversions from rectangular to polar form, and there's a lot of work in what we're going to do today, so I really don't want to go through the process of sketching the picture and finding the r and finding the theta. Instead, I'm going to show you how to do this on the Inspire. You can also do this on an 84 if you have an 84. So on the Inspire, I'm going to go to the catalog, and then I want to change from rectangular to polar. So if I type the letter R, and I'm in the first tab of the catalog, then you see I have this R to P theta, and right underneath there I have R to PR. That's where I can convert from rectangular to polar and find the R and the theta that I need. So I'm doing RPR, and I'm going to enter the real part first as the first argument, and then a comma, and then I'm going to enter the imaginary part, just the number without the I. That's the imaginary part. Now when I press enter, it tells me that my R value is 2. And then I want to do the same thing, go back to the catalog, I want to find my theta, and my arguments are going to be the same to find the theta. And I find that my angle is 60. My calculator is in degrees, so it's giving me that answer in degrees. So I know that this number that's inside the parentheses right here has an R of 2 and a CIS of 60. And I want to raise that to the 8th power. Now that it's in polar form, I can use the theorem from the previous slide, and I know that the R of 2 is going to be raised to the 8th power, and then I'm going to have CIS, and the angle 60 is going to be multiplied by 8, which gives me 2 to the 8th CIS 480 degrees. Now 480 is not in the first revolution of the circle, and if I'm going to use it, then it's going to be more convenient to have it be between, have that angle be between 0 and 360. So I want to find the angle that's coterminal with 480. 2 to the 8th is 256. And then if I subtract 360 from 480, I get 120 degrees. So this is my answer in polar form for 2 CIS 60 raised to the 8th power. You're only going to get one answer when you're raising a number to a power. Now I want to convert this back to rectangular form, so pay attention to your instructions. And to do that, it's just 256 times cosine of 120. Remember that when you're evaluating cosine or trig values, there's a plus or a minus, which comes from what quadrant the angle is in, and there's also the value of that. So I have a reference angle of 60, but 120 is in quadrant 2. The cosine is going to be negative, and using your hand trick, you find that it's negative 1/2. And then your sine is going to be positive, and the sine of 60 degrees is square root of 3 over 2. Now we just need to simplify that. So I get negative 128, distributing the 256, plus 128 I times the square root of 3.